Well, welcome everyone. Hello, welcome to this practical session, Simplifying Thermal Analysis for Universities. Thank you very much for joining us today. We're very excited to be joining by two professors, Pablo and Michael, so thank you very much for joining as well. In this webinar, we will show how Radian is currently used by academics, by universities to teach about thermal analysis. And this is the agenda that you can see in the screen. So I'll give a few words on Radian in case some of you don't know about Radian systems, and then we will move on into different professors to explain their experiences with our software. So as some of you know, Radian is started in 2018, and Radian started as a project when we discovered that the thermal analysis tools that were out there for satellites and for predicting the temperatures of the satellites, they were super complicated to use. And engineers were spending 5 to 6 months to learn how to use a software instead of actually focusing in the engineering tasks. So once we discovered this and we talked with a lot of professionals and everyone complained about these tools, we decided to create our own software. And we developed the first and only cloud-based software for thermal analysis that is in the cloud. And the idea has always been to simplify thermal analysis for space, and the goal is to simplify it. So in 2019 is when we incorporated the company. In that year was also when the first satellite was launched with our simulations, validating our software in orbit. And since then, since 2019, there's been more than 30 satellites that have been launched to space with our simulations, and we work with several organizations in different parts of the world, here in Spain, in Europe, the UK, and also the US recently as well. Different organizations use our software to develop picosatellites to CubeSats, so as big as 16U, and now we're also moving towards microsatellites. So we're very happy with all this development. And the software can be used for both cases, academic and commercial. And we actually realized that because our goal was to simplify the thermal analysis, and we've created this very intuitive platform, it was actually ideal for universities to teach about thermal analysis. And there's two main cases that universities can use our software Radian for. The first one of them would be for CubeSat projects. So this would be similar to commercial case where a company might be developing a CubeSat, small satellites. Also students and student teams can use Radian both in an academic fashion, so for example, as part of the curriculum, or sometimes as team projects that might be part of other programs like ESA programs like Fly Your Satellite, or even in the US as well. And so that would be the first type of project. But today in this session, we're going to focus in the second use cases for universities, that is how to use Radian for practical lessons. So we know that there's some students that are very lucky and they get a lot of knowledge on thermal analysis because they might be part of a master's that has a subject that is only focused on thermal, and I'm very envious of these students. I think that those are very lucky students. But to be honest, not all students are that lucky, right? Because in the aerospace engineering degree, usually what we see is that universities offer like a space systems engineering course or maybe spacecraft design course. And within this course, of course, there's other fields to cover, not only thermal analysis, but they might study about structures and power and the other subsystems. So we see that at the end is only a few weeks, perhaps 2 or 3 weeks, that the students can delve into the thermal analysis and dig deeper. And so it's usually very, very superficial, and you don't get to see so much as we would like, right? So this is where we think that Radian comes in very handy, because we've created this platform that is very user-friendly. So with a few clicks, the students can simulate a box and see what the effects are of all the different space environment. And we will see this in this practical example that we'll see today. And so yeah, this is the two main uses for universities, CubeSat projects and practical sessions. And today's webinar is more focusing this second part of the practical sessions. And with this introduction, I'd like to hand over to Michael Swartwout to tell us a little bit more about how they use Radian in St. Louis University. Michael, the floor is yours.
All right, thank you, Laura. So, in fact, Laura said a lot of the introduction material. So just in terms of background, I teach a lot of the aerospace related courses, or especially the spacecraft related courses in our undergraduate aerospace engineering curriculum. And the issues of thermal analysis, or even just understanding heat transfer, became more critical because we have been making changes, adjustments to our curriculum. And one of the changes in order to make room for some new courses was we got rid of the requirement for our aerospace engineering students to take a dedicated heat transfer course. And granted, in heat transfer course, the undergraduate level is primarily terrestrial, pipes and exchangers and things like that. But that's the only place that our students really get into the engineering side of thermodynamics. And so with that course no longer being required, the only real instance of the spacecraft engineering or the aerospace engineering students seeing thermal is in this spacecraft design course. So as Laura was saying, we're one of those where I have in the span of the semester about 2 to 3 weeks to focus on the thermal design parts. And so again, now that the students don't have that background material, I'm having to cover more of the physics behind it as well. So that in terms of the background, in terms of where we are. So we have a newly required spacecraft design course. All of our aerospace engineering students take that course, whether they're spacecraft or aeronautic focused. And so this was the first time that we've done it in class using Radian. And what we had them do is that the Radian has provided a series of tutorials. The students all individually worked on those, did the design work, the development work, and then later in the semester, they have a culminating design project where, once again, in groups, each group was assigned a mission, a concept, and they had to use Radian for the thermal analysis, thermal design part of that. So overall, in terms of the experience, that I found that the students, I think as they had mentioned earlier, the ramp up time was very short, and I can experimentally demonstrate that because they only had 2 weeks in terms of the licensing to get the project done, and all of them were able to complete the main tasks. Some of those tasks involved learning how to use the software, but some of it was they were doing hand calculations for basic sizing, and then they were doing the full analysis, and they were comparing, contrasting performance. And so they were able to get through those things in a relatively short period of time. And then again, at the end with the design project, the students were able to go through the steps in terms of developing a more complex spacecraft. In fact, in this case, they were doing moon orbits and had to look at the difference in performance for Earth orbiting and lunar orbiting designs. And so, again, overall, I found that the software packaging, it was very straightforward to use. The Radiant team was very responsive in terms of if we had troubleshooting or had questions in terms of the students being able to get their questions answered. Probably, practically speaking, since we're in the United States and they're in Europe, that time difference actually probably worked in my students' advantage, because of course they were asking questions at hours a little more conducive to conversations with Europe. And so the timing and everything like that, it worked out as well, where there was a really fast turnaround on questions. I'll save the rest of the comments for if there's general discussion and questions at the end, but that was the general experience and what we've seen.
Thank you, Michael. I think that was really good to get a little bit of your perspective. And it's very interesting that you also got to use the lunar part, because with Radian, you can simulate usually the most of the orbits that are simulated are around the Earth, but we can also simulate things in the moon or any other planet or body of the solar system. And we've actually been requested by other universities to put, for example, some weird asteroids like Ceres or Apophis, and it gets very interesting for students. And I also wanted to ask you, Michael, in terms of the license manager, how did you find that experience? Was that useful?
Oh yeah, so for those that have course management systems and that where students are uploading things and you're reviewing them, this is not integrated with our course management system, but it had the similar function, which is as the instructor, I could see all of the student projects. So rather than having them create files and emailing them to me and then I'm having to run them in something, I could just log in, go into their project and run the reports and everything, you know, once they had set them up. And that very much accelerated my ability to, well, practically to grade, but also when they were having questions about, you know, does this result make sense? I could very easily, very quickly go check on what they're doing. And then, you know, that has the other effect that you could also tell the students who hadn't quite gotten around to doing the homework. It was very clear where they were or they weren't. So yeah, I found that part seamless. And for those, I'm sure we've all had the experience of licensing and trying to work with your IT to get the licenses installed and those sorts of delays. The cloud-based is really nice to just have that up and ready to go almost immediately.
Great. Thank you so much, Michael. That was great. And yeah, we can leave a bit more for the questions and answers in case there's anyone that has any questions later. And now we can move on to Pablo. So yeah, Pablo, the floor is yours in case you'd like to share your experience with us.
Thank you, Laura. So in order not to have my face all the time, so I prepared some slides, but they're very short. Don't worry, it's not going to be a course. So allow me to share the screen just a second. And now it should be shared. And if I put it in like this, okay. So as I mentioned, it's simply put. So as usual, okay. Now it doesn't allow me to do it this way. Okay, so now should be done. Thank you. So yeah, we've been using Radian in the university for already 3 years, and the aim of this collaboration we have with Radian was very similar to what Michael presented, because thermal courses and thermal theory in the aerospace curriculum is quite dispersed, and especially in undergraduate degrees where you have to sacrifice some courses to fit everything in the same 4 years. At least that's how in Europe works. And the problem is that you need to sacrifice something, and thermal analysis is linked to the master course. So the undergraduate degree lacks a bit of what thermal analysis and thermal theory, how heat works in the process of the design. So in the 4th year, when general subjects appear, like design of aircraft or design of space vehicles, in my case, you have to teach not only the application of a heat exchanger or a heater or a coating for a satellite, you have to also teach how heat works. And in particular, if we go for the space environment, heat and radiation is quite complex. At least in my experience in the past, when they teach me how this thing works and how it is used in aerospace engineering, at least at that level, it was quite abstract. And it was not until I had the opportunity to play around with some software that was quite complex at the beginning, you start getting the point, and you start learning really how to use it and how the effects of some radiation in a wall or in a satellite works. So once I started, I became a professor, and I started to ask how to teach this kind of things to my students that they don't have almost no background about thermal analysis. Then you need to find a solution so you can teach how to design a satellite, because you can teach the structure, you can teach the power, you can show how to design and how to implement all the different subsystems into the whole picture. But the thermal was always, the thermal system was always a problem. So it's been a little bit of a war, and Radian has helped us a lot to fight it. And so far, as I mentioned in the slide, with continuous improvement. So if we see the results of the tests and the projects, the results of the projects the students developed through the course 3 years ago, and we see it this last year, we see a clear improvement on the ideas they came through this time of learning and the concepts they have for mind when they finish the course. They understand why the coatings are the way they are. They understand the differences between an environment on Earth, low Earth orbit, geostationary orbit. If we want to go to another configuration that is not the Earth system, we want to go to Jupiter or want to go to an asteroid, we are the ones asking for that kind of things. If you want, they are able to understand the requirements in terms of what kind of coating, what kind of internal heating the satellite will need to survive in that situation. And little by little, we are reaching solutions with the students that, of course, they are not ideal, because the ideal thing will be that they have a full course on thermal theory, a full course on radiation theory, and then they come with to us to teach them how to design a space vehicle or a satellite. But at this moment, this compromise between the little time we have to teach this kind of subjects and the solutions that our students come with at the end of the course, I think we are very satisfied. And we have to thank that to Radian, like at 80%, I would say, or 90%, because more and more we are finding that the students are find easier to learn by doing, which is not always the case, or was not always the case in the past. But now they tend to lose the fear to work with an application or with a software, and they prefer to do it without having to interact with the equations. And in radiation, where the equations are not even the whole picture, because there are a lot of more complex phenomena involved, that's kind of the optimal thing. So having a software that is able to solve this kind of problems or this kind of inconvenience is wonderful. So just to mention the learn by doing, and also we can teach them how the lamp parameter method works, how ray tracing works, how to do a Monte Carlo. But when they translate these equations, these ideas into a solution, they see the walls of a satellite being heated, and they can follow the temperatures through an orbit. They understand what these kind of things means, and that's the good solution that we are finding today with this software. Just a little bit to mention after that, not only we are doing teaching, we are also trying to do some research in our free time. And one of the projects we have in mind is to analyze the thermal configuration of that structure over there, which is an origami-inspired one. Some of the people in the audience know that. So that's an origami demonstrator for a CubeSat, and we are trying to test how it will behave thermally speaking in low Earth orbit. And hopefully we manage to do it with the help of David and Laura. Just not only to put some text, I'm showing you some results. This kind of solutions from an undergraduate student, I was not expecting to have them like a couple of years ago, and this is 2022, 2023, two missions. They were able to test these configurations that the students came with the ideas of the structure and the shape and the orbit from some requirements. You can imagine the kind of working process. And when they reach the part, which is almost the last one, most of the times, to test and to analyze the thermal evolution of the inner parts of their satellites, they were able to do it thanks to Radian, and to come with solutions that made sense, which was sometimes the difficult part is not for students to get results. It's for students to get results that make sense. And that's some very important solution that people from Radian helps us to manage. I'd like to speak a lot. That's what I'm a professor, so I'm sorry if I speak too much. I'll leave the floor for questions. we can speak after in case you're more interested in the details.
Thank you very much, Pablo. No, that was great. Thank you so much for showing these results. I think it's always great to see some CubeSats and some of the work that your students have done. This is fantastic. And I think also there's a bit different to Michael in San Luis, because San Luis is a bit far. We haven't been able to be physically with them in those practical sessions, but with you, we've actually been also in the class, right? So you've also had the experience of having David both remotely, but also with you there in the class. So I don't know if you want to say a few words of those practical sessions.
Yeah, I mean, David passed by Madrid. He was in the classroom with the computer, and at the same time, we were proposing the students some problems in kind of a practical session, right? So they will have to follow David, the instructions David was giving them, and trying to translate what I taught them last session with what David was trying to tell them to do with the software. And although the first steps were kind of difficult, after half an hour or 45 minutes, all the class, almost everyone, you know, there is always someone that takes a little bit more, but almost everyone was able to come with the solution of a little enclosure with a heater inside, and seeing how that enclosure evolves around the Earth. So amazing experience.
That's great. Thank you so much. Yeah, I think it's very, very important to do what you mentioned of learning by doing, right? Because it's very important to have the theory and understand the theory, but then sometimes it clicks in your mind when you're doing some like practical exercises, and that's exactly what we want to do with Radian, and the purpose of our software is exactly that, like allow these type of tools that are useful and user-friendly as well. So thank you very much, Pablo. And now I think we can move on to the last part of the session, and probably the one that everyone's looking forward to, that is actually seeing the software. So David, I hand over to you if you want to show us.
And before I share my screen and I start with that part, I would like to complement what you just said in terms of also not only being in person, but sometimes these practical lessons entail sharing the screen and doing it remotely, and being able to dive into each of the students' results and showing the rest of the class what is being done good and what is being done not so good, so that they all learn from each other's mistakes. That's also an advantage that we are taking, that we're making use of. So yeah, I'm going to share my screen and I'm going to show you the tool, but in a different way, because we usually show it in a general way, but there's more to it, especially when it comes to universities and the academic community. We're able to have, as these two professors said, and also Laura, we're able to provide it with some special features that make it more appealing to universities. So as you can see, and as Laura said, we're a cloud-based software, and as such, we are accessed via a web browser. Right now, I'm using Mozilla Firefox, and I'm just typing the URL app.radian.systems that you can access it to our website once you have the users enabled, your license enabled. And I'm typing in here my user credentials, my demo user credentials, username, password. I click login, and I'm in. So I enter our product. This is the home view of Radian. In the home view, you have a list of your projects, not only the projects created by you, but also the projects shared with you. And this is the first distinction that we have for universities. So each student will create his or her own projects, and he or she will only access his or her own projects, and those only. But the professor will have an overview of all of the projects that the students create. And in here you have an example of what the professor sees. So the professor will have his or her own examples created here, or projects, either academic or university research projects. And beneath that, he or she will have access to each of the projects that the students created. So in this case, we have two different students with two different projects, but they're probably the same project for the class, but with different names. and the professor can access both of them. Not only in this view you can access your projects, but also here in the navigation bar. You can access the home view, the list of your projects, and also the projects shared with you. You can also navigate through the data bank, and this is the catalog that we provide to every user in Radian so that you can reuse satellite components, material definitions, surface coatings, orbit, attitude models, and also attitude files. And you can use them across as many models and scenarios as you want. So you just need to define them once, and then you can use them as many times as you want. And finally, a support site as well, and some user settings here that we will visit in a bit. So if thinking right now that I'm a professor, if I click on one of these projects from one of the students, I can access the whole thing. So I can see the projects and the models that the student has created. In this case, this is just a simple plate for showing purposes. We can also not only see the different parameters and entities that the students created, but also the results. So for instance, if I go here to the thermal results that this student has been computed, as I was mentioning right at the beginning of my intervention, we can actually plot the temperatures, and maybe, as I'm doing today, share my screen with the rest of the class, showing them the results, compare them amongst the other students, and just derive conclusions from there. So as you can see, everything is very intuitive. There is no file management. There is no sending emails, sharing information, URLs. Everything is in a single solution, in a single product. So the professor will have access to all of that. As you can see here, we have also the name of the student that is the owner of these data. The second distinction that we have in Radian for the academic community is the license manager. So besides managing the contents of the students, you can also manage the licenses themselves. So in this example, we have 4 licenses. So this license is the license of the student, sorry, the license of the professor, which has not only thermal analysis permissions to carry out thermal analysis, but also license management permissions. And these permissions are the ones that actually, or is the one that actually allows him to enter into this view. We also have 2 licenses for the 2 students, John Doe and Jane Smith, and these 2 can be actually edited as well. So if there's a student that has concluded the activities, and there's another student that wants to resume those activities, the professor can actually unassign and reassign the license. Also, there's here an empty license, and these licenses are highlighted in yellow so that the professor sees them really quickly and can assign them to users, because they're probably a waste of resources. So if you click on one of them, you can just create the first name, last name, and the email of the student that will be using the license for the time that is allocated. And as you can see, this triggers an email delivery. This means that the student will receive an email with the onboarding instructions. He or she will set up the password and will start using Radian, inputting his username and password, just as you saw that I did right before. So if I go back to the home view, I will now show you one of the simple tutorials that we have in terms of the content that we provide to universities, so they can actually create these first little projects and tests for the users, for the students, so they get used to thermal analysis in a very simple way. And then they can create their own projects as complex as the one that Pablo showed you before. So in here we have the project view. We have divided projects into models, scenarios, and analysis cases. Models comprise your geometry, contacts, and heat loads, all kinds of boundary conditions. Scenarios mean they entail the orbital parameters, attitude, time parameters when they're mission, scenarios, but you can also create enclosure scenarios for isolated environments with custom boundary conditions as well. And finally, the analysis cases are about thermal solutions, and in Radian you can create three types of thermal solutions, either transient, generic transient solutions, periodic transient solutions that are iterated over and over, and steady state solutions as well. So if I click here on the model, you will see that this is a very, very simple model for students. This is in our materials, and this is what we provide for universities as the first exercise, which is just to create a cube out of 6 plates that are the sides of the cube, and then a computer within that structure, simulating a 1U CubeSat. Very, very simple. So they get their first sense of thermal analysis. So they need to create all of that. They need to compute the contacts, which are detected by proximity, and also they need to input here a contact that is actually connecting the computer to one of the sides of the computer, and finally a heat load. And then in the second stage of this tutorial, they need to create a battery as well, represented by another solid box. They need to connect the battery to one of the sides of the structure as well, and finally create a heating load state that we will see later. So before all of that is made, we have we create a scenario with no heating capability. As you see here, we have the load events that represent when these heat loads are actually taking place, and there is no load event for the battery, only a load event for the heating. We will add this live later. And to the right side of the screen, we have the mission parameters, as I said, the orbit that can be placed around any body in the solar system, the attitude configuration, which is a sequence of attitudes configurations or definitions that can either be attitude models or attitude files as well that you can upload with quaternions to the platform as well for custom orientations. And finally, we have the lifespan that entails when the simulation is actually taking place in real time, how long the simulation is going to take place, and the step at which the external heat fluxes will be probed. And as you can see, well, you have the time slider to check how the model will be placed along the simulation. And to the left side, besides boundary conditions, we have load events, and let me dive a little bit deeper into what these mean. So you have different load states created, and now you can actually specify when these load states can actually be activated. So you can actually activate them as a custom sequence all along the entire scenario in a periodic fashion. You can bind them to attitude events, active only. You can activate them only during eclipse or out of eclipse as well. And finally, we have the transient periodic solution that calculates the temperatures for this scenario. I won't be diving into the parameters now, but we can go straight to the results and see what needs to be done. So what we ask students to do in this first tutorial is actually to check, once the battery is added, is to check the battery temperatures that we can check here in these XY plots really quickly. We can also plot the ranges as well. But if I hide all the series, collapse, and show the battery, we see that the battery, as you can see also here, has temperatures between 56 and 30, almost 40 degrees. So what we ask the students to do is to find a temperature in between, which probably could be around 46, 45 degrees, and then apply that as the set point of the heater. So once we have the set point enabled, we need to check that effectively the heater is actually being active when the battery drops, when the battery's temperature drops below that set point, and that the heater actually works. And this is for them to actually know how heaters work in a very simple way, because as you can see, the battery here is well above what we all know as the common temperature range for a battery. But this is just for the students to get a sense of how a heater would work in real life. So if I go back to the project tree, I can actually select this scenario and just duplicate it. And as simple as that, I have now a new scenario, and this I will rename into Leo heater. And this will mean that this scenario will have a different operational mode. And in that operational mode, we will activate the heating load state that you saw before here. So the students are asked to create this load state for the battery, because the battery will have the heater, is supposed to have the heater within, and you need to create a heat load of 1 watt, select it as a heating load that is dependent on the temperature of the battery node itself. And then, as you can see here, the enable point is at 45 degrees, which is one of these temperatures in between, and the disable point will be set 10 degrees above that. So once they've done that, if they run the simulation now, they will get the same results, because there's no load event created for the battery heating state. So now what I need to do is just select the battery, select the heating state, click on perpetual, and now I will have created the heating event, so that the heater will be watching the battery temperature across along the whole simulation. So now if I go to the results and I go to the next step, which is the thermal solution, and I compute the temperatures for the whole satellite, but what we're interested actually is the battery, I plot the results again, and you see now how the temperature of the battery is actually behaving differently. So if I hide all the series and I plot only the battery, you see that the battery stops right at the 45 because the heater has been enabled. And how do I know that? Well, I can also click on the duty cycles and see how often or how much of the orbit the heater is actually active, which is 9%. But if I want to see exactly when the heater is active, which makes sense that it's just when these peaks appear, I can also plot the dissipative heat plot and check how the heater is actually being active with 1 watt of dissipation just when the battery temperature stops dropping. So this is how, with several visual elements, we show the students how the different active and passive thermal control elements can be added to a model, and the repercussions that their addition have in the model itself. I can also show you another views as well of the satellite. We can also plot them as in the model, and just show the temperatures of each of the components that you can see visually. And we can also correlate that with the orbital position, and we can get different magnitudes and different sources of data, like temperatures, but other types of heat balances as well, and correlate those with the orbital position of the model across the orbit. So this is how everything is plotted and computed in Radian in a very basic way. I hope that this was not too long, and now we have more than enough time for questions and doubts. We can dive into other aspects of the tool if you want. That's why we're here today. So please feel free to ask as many questions as you want. And thank you.
Thank you very much, David. So yeah, now I think it's the moment for questions. So any questions? I think here we have people from all over the world. So thank you so much for joining us. And if you have any questions, now is the time. Feel free to put them in the chat, or you can also turn on your camera and microphone, and we can have a chat. We can share your screen if you have any specific questions on this software, or we can also reply here. Also feel free to ask any questions to the teacher that we have with us, Pablo and Michael, on their experience, if you have any questions regarding that. have no questions. That means that everything is super clear. David, our goal is accomplished.
Yeah, I actually skipped that part, but now Jordi is actually asking us for the importing of CAD files. So let me share my screen again and show how CAD files can be imported. Okay, so let me share again, hopefully. So I skipped this part on purpose because we usually don't expect students to import CAD files in practical lessons since day one, but it is true that they use the CAD importer for other projects, assignments from their professors, and also other academic projects. So in here, if I'm showing you again the project view, and if I go to the create new model, I can either create a blank model and generate it from geometries, as you saw that these other models were created, just selecting plates or the type of geometry that you want to create, and then just configuring it the necessary attributes like material, position, dimensions, and so forth. But I can also straight import a CAD file. So CAD files can be up to 60 megabytes and in the step format. And once you enter here a model and a model name for the CAD file, we ask you to remove pieces that are smaller than ideally 1,000 cubic millimeters. This is a cube of 1 centimeter inside. In thermal models, as you know, things like screws, bolts, hinges, they are idealized and simplified and replaced by conductive links or GLs with the appropriate conduction value. So that's why we save the effort to the user, just having a rule of volume with which we remove the tiny pieces from the CAD file, and we start simplifying the rest of the geometries. So once you upload the file, you will endure 3 steps. The first step is filtering any other geometry that you don't want in the file. The second step is about simplifying the geometries, because as you know, geometries usually have indents, chamfers, pockets, holes that are not recognized by thermal model softwares in general. So we need to adapt them and accommodate them to Radian. And finally, you just can configure them a material, rename them, group them in parts, and eventually you just export the thermal model, and one of these models is created automatically in the tool. So that's how you can import a CAD file from SolidWorks, CATIA, AutoCAD, or any other CAD tool that you are using today.
And just to add to what David was mentioning, I think the CAD importer is one of the best features that we currently have. It's something that everyone was asking us since 2019 when we started the company. So we're now very happy that this is implemented. So yeah, now this is available for everyone to use it.
I think we have more questions in the chat. Laura, probably you want to
Yep. So
moderate.
yeah, thank you so much for your question. The question is regarding oh, sorry, there's more questions, but yeah, the question is regarding how to get a license to try it out. And yeah, this is something we currently provide. So if you can send us an email to laura@radian.systems, I can arrange for you to get a trial period. We give a 1-month trial period so that you can test the tool and see if it's useful for the projects that you're working on. So thank you very much. We also have another question from Constantinos. So David, Constantino is asking, can you model different zones of albedo and Earth IR on the planet, for example, with latitude?
So right now we have a model in the backend in the simulation engine that is connecting the albedo values and the infrared values with the latitude, especially because, as you saw in the viewer, we know how Earth is actually positioned not only in latitude but also in longitude in real time. So we could actually correlate these areas. But this is something that we have not implemented into the front end, into the application. So we have it in the simulation engine, but it's just a matter of bringing the model up to the interface. So if there's a need, and either Konstantinos or any other person that is today attending or seeing this video later on wants to have this feature implemented, it will be just a matter of bringing what we have already developed in the simulation engine to the interface. So yeah, this is actually half developed.
Yeah, 100%. And regarding this point, we always love feedback from users or potential users, because anything that you're interested in or you want to do for doing thermal analysis in space, I'm sure that other people will be asking in the future. So we love to get feedback. We have a long list of features that we want to develop next and our technical roadmap, but any feedback or ideas or suggestions like this, they help us a lot to guide our roadmap. So yeah, please let us know. Here's my email, laura@radian.systems. So feel free to send us an email, and we can organize a video call or give you access for a trial period if that's needed.
If I may, Laura, I'd like to answer to Jordi's last question. Jordi says, is it possible to do research and publish it with an academic license? Yes, of course. Actually, so academic licenses are meant for universities because they are prone to purchase a higher number of licenses for us, but also because there's no commercial intent in their uses. So as long as there is no commercial intent, we can sell those licenses as academic in the academic tier, as long as that is fulfilled. So there could be the case of us selling a commercial license to a university group, research group that is actually working for a company and delivering consulting services, but that's just like a corner case in a very specific case, and that's not usually what we encounter. So
yeah, and just to add to David's comments, the commercial and academic licenses at the moment, they are offering pretty much the same performance. So it's not that you get use capacity or performance because it's academic, it's mostly for the use that's going to be used for.
Exactly.
Okay. All right.
Okay.
Is there any other questions? You can always reach out to us, and we're very happy to have a call and go in more detail on your type of subjects. We'd love to get also feedback on, how do you do thermal analysis at university now, especially for aerospace engineering or masters on space engineering. And we'd love to be able to help with those subjects and classes. So please do reach out. And if there's no more questions, perhaps we can finish here. I don't know, David, if you want to say some last words or some last comments.
I would like to thank you all for being here today. It's been a great pleasure, especially knowing that the Starship was launching today. Thank you all for attending. Thank you all for your interest. It really means the world. We've been building this with great care for many years. This has been really difficult to actually meet the expectations of the academic community and also the private companies as well. They differ, but sometimes they align, and we need to be there for all of them. And we would like this product to be the best in the world. We would like us to be the default option in thermal analysis. And we're going step by step. We are addressing the academic community today, but we are planning to do a webinar for private companies as well in the future. So make sure to actually talk to your acquaintances in the private sector as well, because that's coming in the coming months. So yeah, I'm just full of gratitude to all of you, especially, and I need to make it special for both professors Pablo Solano and Michael Swartwout for making time and making room in their agendas, which are pretty busy today. And also finally and eventually my co-founder Laura, which I think has been playing an amazing role today. So thank you all of you.
Thank you very much, everyone. I think with this we can finish the webinar today, and we'll be really looking forward to have your emails and talk a little bit more with you. So thank you very much.